So, good morning, everyone. So, welcome to today's lecture, Functions of Random Variable. It is lecture third. So, today we are going to start new topic, expectations and variance. Okay. So, what is expected value? Okay. So, let x be a random variable. Okay. Then the expected value. This is also called mean value. Ex of x is defined as Ex is equal to summation I goes to 1 to infinity xi p xi. In the case of discrete random variable, if you have a discrete random variable, the expectation is defined like this. Okay, let's say it 1. And if you have a continuous random variable, expectation is defined by this way. CRV, continuous random. In the case of continuous random variable, expectation is defined like this way. Okay. So where this is important, where the series in one equation 1 and the integral and the improper integral in 2 is absolutely convergent. What is the meaning of absolutely convergent? The meaning is that you take absolute value of inside terms. Okay. In this series, in the equation 1, it is given. So you take absolute value of this, each term. Because probability mass function is non-negative, so there is no meaning of. So how to write this? Because probability mass distribution is non-negative. So if you put absolute value of p xi, it will be non, because it is non-negative. So absolute will not affect anything. It will remain as it is. So absolutely convergent means this should be finite value. Okay. Similarly, integral is absolutely convergent means you take absolute value of the function. What is that? Okay. So example, sample space you take 1, 2, 3, 4, 5, 6. Okay, and you are taking random variable this. Okay, so probability you are taking 1 upon 6. Each term is 1 upon 6. Then what is the expectation? Can you tell me? This is discrete random variable or continuous random variable? Tell me. Discrete. So which formula you will apply? First one. So what is that? That is I goes to 1 to because 6 xi p x xi. So what is this? This is 1 into 1 upon 6 plus 2 into 1 upon 6, 3 into 1 upon 6, 4 into 1 upon 6, 5 into 1 upon 6 plus 6 into 1 upon 6. So 6 will be common in denominator. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. How to write 1 plus 2 plus n into n plus 1 by 2. So this is numerator thing is 6 into 6 plus 1 by 2 upon 6. 6 से 6 cancel हो गया. So 7 by 2. It means 3.5. So expected value need not be part of sample space. Always remember. Because 3.5 is not belonging to sample space. So expected value is a numerical value. It does not need to be belonging in sample space. Okay. Question, example number 2. Have you note down it? Example number 2. Note it. Example 2. Find the expectation of binomial random variable. Okay. We need to find expectation of binomial random variable. Okay. If you remember uh, if you remember okay, if you remember that in binomial distribution, this value is given by this way. If you remember, n upon factorial k n minus k, okay, p to the power k 1 minus p to the power n minus k. Okay, in binomial distribution, the probability mass function is given by this way. If you remember, you can recall it. Okay, then what will be the? Can you tell me what will be the expectation? So Ex will be equal to summation k goes to 0 to n k into px k. Okay, k goes to 0 to n k into factorial n upon factorial k factorial n minus k p to the power k 1 minus p to the power n minus k. Okay, so put s is equal to k minus 1. This implies k is equal to s plus 1. So when k is equal to 1, when k is equal to 1, this implies s is equal to 0. And when k is equal to n, this implies s is equal to n minus 1. So, so this integral, so this summation will be changing to, I am changing this summation in the s. So what will be? S goes to 0 to n minus 1. Okay. Factorial n upon s plus 1. Okay. Sorry. 1 minute. So first you observe that this summation I can write in this form. Summation k goes to 0 to n. 1 factorial n upon factorial k minus 1, because we can open factorial k into factorial k minus 1. k से k कैंसिल हो जाएगा, n minus k p to the power k 1 minus p to the power n minus k. Now we have taken s is equal to k minus 1. Okay, so what will be this? This will be, in place of k minus 1 I can put s. Okay, and this will be n minus 1 minus s. Okay, k का वैल्यू रख दो, क्या आएगा? p s plus 1 1 minus p n minus s minus 1. Okay, so 1p I can take outside. If I take 1p outside, okay, so 1p I can take outside, and this is factorial n. So basically what I am doing, factorial n I can write n into factorial n minus 1, factorial s, factorial n minus s minus 1. p to the power s plus 1 I can write okay, n and p I can take outside, n and p I can take outside, so it will be np summation s goes to 0 to n minus 1 factorial n minus 1 factorial s factorial n minus 1 minus s p to the power s 1 minus p to the power n minus 1 minus s. Can you tell me how to write this now? What is the, in short form I want to write it. Can you tell me how I can write it? Tell me, how can I write it? How can I write it? Can you tell me? What is the formula of a plus b to the power n? Can you, it is formula of p plus 1 minus p to the power n minus 1. You can check it. So np is already there. So p से p कैंसिल हो जाएगा. तो np और 1 का पावर n minus 1. So what is 1 ka power n minus 1 means 1. So you got np. So expected value in binomial distribution is actually np. Okay. So I have written this p plus 1 minus p to the power n minus 1 by binomial theorem. a plus b to the power n का फॉर्मूला अगर आप खोलोगे तो क्या आएगा, वो इसी तरह से आप चेक कर सकते हो, है कि नहीं. थ्योरम x x is uniform distribution. Uniform distribution is written like this way. Then expected value of this is nothing but a plus b by 2. Okay. Solution. Can you tell me in uniform distribution what is the probability density function? Can you tell me please? What is the probability density function in uniform distribution? Can you tell me please? What is the probability density function in uniform distribution? 1 upon b minus a if x lies between a and b, otherwise it is 0. So in uniform distribution, in the uniform distribution, what is the probability density function? It is given like this way. It is 1 upon b minus a if x lies between this and otherwise 0, elsewhere 0. Now I need to calculate expected value. So how to calculate expected value? Because this is a continuous random variable. What is the formula for expected value? Minus infinity to infinity x so what will be this? Because except the interval ab all thing is 0, fx is 0, then what will be this? A to b x 1 upon b minus a dx. So 1 upon b minus a is constant, it will come out a to b x dx. So what is this then? 1 upon b minus a x square by 2 a to b. So 2 is also constant, 2 will come out b square minus a square 1 upon 2 b minus a. So formula we can open b minus a, b plus a. So this is cancel out. So we got finally a plus b by 2. So that is proved. Okay, any doubt in this? Now we are going to study expectation of a function of random variable. Expectation of a function of random variable. Theorem. Let x be a random variable and let y is equal to hx. First part, expectation of y. How to write expected value of y. Y is a function of x. It means function of random variable x. How to write its value? Yeah, it is simple. Summation I goes to 1 to infinity h x I p x x I. If your random variable, in the case if discrete random variable, if your random variable is discrete, you x is discrete random variable, this value will be this. Okay. In the continuous, in the case of continuous, it will be given by that will not change. Probability will remain as it is. So minus infinity to infinity hx dx if continuous random variable. Okay. So example, let b be the wind velocity meter per hour, and suppose that v is uniformly distributed over the interval close interval 0 and 10, the pressure say w. Okay. In lb feet square, maybe unit of lb is pressure unit. Okay. What is that? lb is something. Okay. On the surface, on the surface of an airplane wing, okay, is given by the relationship w is equal to 0.003 v square. Okay. Find the expected value EW. Okay, we need to calculate this. Solution. So EW uniform distribution is given 0 to 10 W. Okay. So 0.003 V square FB. Okay. 0 to 1 10 0.00 V square. So this is the value of this. What is this? 1 upon, because it is uniform. 1 upon 10 dV. So what will be this? After solving it, you will get this one. LB feet square. Okay. Now, expectation of function of two-dimensional random variable. Okay. Theorem. Let x, y be a two-dimensional random variable. Okay. And let z is equal to hxy. Then what will be this expectation of z? What will be this? I goes to 1 to infinity. Sorry, j goes to 1 to infinity. I goes to 1 to infinity. H x I y I p x I y I. Okay. So joint probability mass function will be given to you. Okay. So this value is given when you have a discrete random variable. Xy is a discrete random variable. Okay. And second, this value will be minus infinity to infinity fxy dx dy in case of continuous random variable. Xy is a continuous random, two-dimensional continuous random variable. Okay. Okay. So next is properties of expectation. Properties of expectation. Okay. So property one, if x is equal to c, where c is a constant, then expected value is given by expected value is c. Okay. If your random variable is constant, then its expected value is also that constant. Okay. So proof, how to write expected value. If you have a continuous, if your random variable is continuous, then you will use this formula. C will come out. Can you tell me what is this value? 1, always 1. This we have done because if x is continuous random variable, we will use formula. If similarly, if discrete random variable, we use summation. So this value is C every time. C will come out. So this is 1. And so if x is discrete random variable, this formula will be used. Okay, every time it is C. Whether it is continuous or discrete, expected value is C. If your random variable is constant. Okay. Are you getting or not? It is clear. Now property 2. If C is a constant, then this is equal to where C is a constant. Okay. So where if suppose I am doing this proof, it is not mentioned it is discrete or continuous. Proof you can do by continuous way. Discrete similar way will follow as I have done earlier. This is on in the only proofs. Okay, no other way. So here x is discrete or continuous, it is not manner. So I am adopting continuous manner. Discrete manner will be similar way. Summation is there. Okay. Okay. So what is this value? Can you tell me? You can put y is equal to c times x. So actually, I am computing the expectation of y. So what will be this? Minus infinity to infinity. Y probability will not change. I already told. So fx dx. You put the value of this c times x. C will come out. So tell me what is this? Tell me what is this? This is ex. So this is proved. Okay. Now property 3. Property 3. Let xy be a two-dimensional random variable with joint PDF let z is equal to h1 xy w is equal to h2 xy, then expectation of z plus w Let's see its proof. So expectation of z plus w, okay, equal to minus infinity to infinity h1 xy plus h2 xy f x y xy dx dy. Okay. Now we can open this integral minus infinity to infinity minus infinity to infinity h1 xy f x y xy dx dy plus minus infinity to infinity h2 xy f xy xy dx dy. Okay. Can you tell me what is this? This is expectation of z, and this is expectation of w. So it is proved. Okay. Now property 4. Okay. So property 4. Let x y be any two random variables, then expectation of x plus y is equal to expectation of x plus expectation of y. So proof is simple. So I can take h1 xy is equal to x, just x, and h2 xy is equal to just y. Okay. By property 3, by previous property 3, we have we have by following the property, this is my z and this is my w. By property third, we have expectation of x plus y is equal to expectation of x plus expectation of y. So it is proved. By property 3, what was the property 3? Okay, h1 should be function of x or y, h2 should be function of y. We are calling this z or w. Expectation of z plus w is expectation of z plus w. Expectation. Similar way, we are taking. Okay. So now can you tell me if A and B are constants? If A and B are constant, then what is the value of this? Can you tell me? Because this is expectation, this is expectation. Similar way by just previous property 4 we can write like that. Okay. Now I have told that if you take constant cx, c will come out. Here a is constant, so a will come out. So we have this one. So expectation of ax plus by is equal to a times expectation x plus b times expectation of y. Similarly, suppose we have summation of random variables like this way. AIXI. So then what will be this similar way? Can you tell me? This will be summation of I goes to 1 to infinity AI expectation of XI. Okay? Similar way. Property 5. Let XY be two-dimensional random variable and suppose that X and Y are independent. Then expectation of XY is equal to expectation of X, okay, into expectation of Y. So let's see its proof. Okay, since X and Y are independent, we have what will be the this relation? Can you tell me? This will be equal to when we have X and Y independent. What is the relation between marginals of X and Y? So what will be expectation of, okay, XY, because product we are taking. We can write this. This is equal to this. Okay. Now we can separate these integrals. Because X or Y functions are not mixed, we can separate. Okay. Now tell me what is this? What is this? Expectation of X. And what is this? Expectation of Y. So we have expectation of XY is equal to expectation of X into expectation of Y. Okay. Okay. Now next topic is variance of a random variable. Variance of random variable. Okay. Let x represents x represents sorry, let x be a random variable. The variance of x is defined as how it is defined. Variance of x is defined by this way. This is square of this. We are denoting this symbol. This is a variance equal to sigma x square. Okay. Expectation of x minus ex. So we are taking expectation of x minus ex के स्क्वायर का एक्सपेक्टेशन ले रहे हैं हम, ठीक है ना. Where is non-negative and this is called standard deviation. Standard deviation of x. In other words, it means standard deviation is both. It is positive under root of variance. Okay. Okay. Please note down it. So स्टैंडर्ड डेविएशन का स्क्वायर कर दो तो वेरिएंस मिल जाता है, और वेरिएंस का पॉजिटिव अंडर रूट ले लो तो स्टैंडर्ड डेविएशन मिल जाता है. ठीक है. नाउ थ्योरम 1, variance of x is actually equal to expectation of x square minus ex का expectation square. This is result. So proof. So it is simple. Bx is equal to, what is the definition of bx? X minus ex का square. So we can open the square inside x square plus ex का square minus 2x ex. Now you see that ex is a numerical value. Ex is a numerical value. It is a constant. Since ex is constant, because expectation of a random variable is a constant value. So what I will get? Apply e value inside ex square. Okay. Now ex is a constant, square is also constant. मैंने बोला था इस constant का expectation constant ही होता है. ex constant है तो इसका expectation क्या होगा? यही होगा. So ex का स्क्वायर और 2ex तो कांस्टेंट है, ये तो बाहर आ जाएगा. ex तो ये क्या होगा? ex का प्लस e now after solving it what you will get? So this is proof. Simple. Okay. Properties of variance. Okay, properties of variance. First property is, what is the first property? Variance of x plus c is equal to variance of x for any constant c. It means if you add a constant to a random variable and take variance, it will not affect anything. Okay, simple. First you calculate what is this, because expectation is what? Variance is what? Variance of x plus c, what will be this? Expectation of x plus c minus e x plus c, okay, का square. This is x plus c. Now, if you will apply expectation take constant to constant. So it is ex plus ec. ec. Okay. So expectation of x plus c minus expectation of x. Expectation of c. What is this? This will be remain c. So c से c cancel out हो गया. So tell me what is this? This is variance of x. Okay. Okay. Property 2. Okay. So we will study next property in the next class. Okay. So thank you very much for today's lecture.